Okay, question number 6. Question 6, I think, is worth 12 marks. We've got 3, 7, 10, 11, and 12. So that's about 20. I think that's 20% of the paper. It's quite a big question. I had a look at the mark scheme and I don't understand why the mark scheme is the way it is. So what we've got here is that the UK government recommends that healthy adults should have a total cholesterol level below 5 millimoles per litre. The total cholesterol level of an adult in the UK can be modelled by a normal distribution. So X can be distributed normally with a mean of 5.6 and a standard deviation of 1.3. Now, what this then wants to happen is that they want you to put that into the standardized normal distribution where the mean is 0 and the standard deviation is 1. But we've got class whizzes, we can work this out without having to go to that level. So, for example, here, there's our standard deviation curve, there's our mean. It says work out the probability that a random chosen adult in the UK has a total cholesterol level below 5, which means that 5.6 would lie here. So if that's 5, we're working out that bit there. So the probability that X is less than 5. And then we put it into our calculator. So I've got an FX, let me just put that there, FX CG50. And then if anybody can tell me how to link that on this video to Amazon to make some dollar, just put a comment and you can always help me out a little bit. But we're going to go into menu. I'm going to write down everything I do here. Menu and then 2 for statistics. 2. And then you're going to hit dist, which gets you to distribution. Norm, because we're doing the normal distribution as opposed to binomial. And then NCD is the normal cumulative distribution. All right, and then we've got our data. This is important. Your data has to be variable. If you haven't done this before on one of these calculators, you are going to have to set that as variable. The lower value is 0 because we're going from 0 up to 5. The upper, of course, is 5. And then they put these the wrong way around, so don't get caught out. That is the standard deviation, which we've got as 1.3. And then that symbol I can never draw, which is the mean, 5.6. So you put those details into your calculator and you'll get the probability that it equals 0.32219,791. In general, for anything I've been doing on statistics, we're looking to have that as 4 significant figures. The mark scheme, though, and I'm going to go to the mark scheme and talk to you about it because it has confused me a little bit. They want you to go through the rigmarole of going to the standard and then bringing it back out again. And the answer is between 0.32 and 0.323. So we've got the correct answer anyway. So I'm happy to do it that way. And it's easier. It's much easier. Okay, that's taken me 3 minutes. Let's get back to the next one. So 6b. Show that approximately 1 in every 3 adults in the UK has a total cholesterol level within 10% of the mean. So let me just explain what this is. So here's our standard deviation. Here's our normal distribution. And in this line is the mean. So our mean on this question is 5.6. Now, if I add 10%, we're going to get 6.16. If I subtract it, we're going to get 5.04. And it wants to know what this is here. What is the probability of finding someone in there? And they're saying we have to show that it's going to be roughly a third. So by showing these 2 values, I've picked up some marks. And then I'm going to put it into my calculator. So again, we go into stats mode. And then we do distribution, normal. On this occasion, we're going to do inv norm. And then we put into this all of the bits we want to know. So the tail is actually central, because as you can see, we're working out a middle part of this diagram. So central, which is F3 on that calculator. The area, what's the area going to be? I think that's 0.2, isn't it? How did I work this out earlier? Can't remember. No, it's not this one. It's not this one. Let's go back. I think it is this one. Ah, yes. My area is going to be a third. That's what I did, because we know that it's a third. We're trying to prove that it's a third. And if it is a third, we're going to get the two values coming out here. So 1/3. The mean and the normal distribution have not changed. And then when I put that in there, sorry, I'm just going to write this in as well. 1.3, and that's 5.6. So when I put that in, my x1 is equal to 5.04005451. My x2 is 6.1594549. So this one matches that, and this one matches that. x1 5.04, x2 is 6.16. And then we've just proved that there. Again, they're trying to get you to use, I think, the standardized, but that way works out nicely. And we've got the values. Okay, estimate the total cholesterol level exceeded by 75% of the adults. So I'm going to put a little line there, because this is going to be our 50% value, because it's the mean. And then this is going to be 25%. And we want to know all of that. So what that's going to do is it's going to tell us, let me see, total cholesterol level. So I'm going to need to know the value of this probability. Again, going to go back into the inverse, normal. But on this question, the tail is going to be on the right, because that's where the shaded bit is. And I hope drawing these diagrams helps you. On the area side of things, exceeded by 75% of the adults. So that's going to be 75%, 0.75. And then it gives me a value of x equals 4.723163332, or 4.72 to 2 decimal places. And again, 3 marks, but a little bit of calculator work. I feel as though, having studied like the second year of statistics, this is easier than, of course, the second year of statistics, but you can just chuck it into the calculator. It's asking for like lots of values, and I guess you're trained on these in lessons, but I've just done these using that calculator in order to get that answer. Right, last couple of bits. Got plenty of time. So 6D, show an appropriate calculation to justify the claim. So a healthcare research company claims that adults in a small town in the UK have a lower total cholesterol level than the mean for all adults in the UK. So the mean, I'm just going to pop in here, is 5.6. They recorded the total cholesterol levels of 10 adults, which makes it nice and easy. So we're going to sum all of these values and divide it by n. Just got to get out of this menu. So 5.5 plus 5.7 plus 3.4 plus 5.8 plus 5.7 plus 3.9 plus 3.7 plus 5.4 plus 4.9 plus 6.1. So 50.1 divided by 10, which gives us 5.01. So their claim is correct. And there's just one way that the company could improve the accuracy of their claim. So what they could do is take a sample size much greater than 10. Because the more pieces of data you've got, the more accurate your claims are. Okay, that's question 6 done. Please, of course, like the video, get plenty of people to watch it, get loads of people subscribing, and I'll see you at question 7.